Imagine carrying your identity and possessions across apps like a digital backpack you alone control. The internet will change how we own things online. Today, you visit pages and log into accounts. Tomorrow, you'll bring a wallet that proves who you are and what you own. That shifts power from platforms to people, but it also shifts responsibility to you. We'll unpack the tech, the risks, and practical steps you can take. First, let's rewind and see how we got here. Web 1 was simple: static pages served by servers. You read content like you read a book. Then Web 2 added comments, photos, and platforms that aggregated audiences. Companies built massive silos and collected user data. That model created convenience and concentration of power. Understanding that history explains why people want something different now. Next, we'll meet the core idea behind Web 3. Web 3 boils down to three verbs: read, write, and own. Instead of passwords, you use cryptographic wallets. Instead of platform accounts, you hold credentials and tokens in that wallet. Apps talk to your wallet with permission, not ownership. That makes identities portable across experiences. It also raises questions about security and usability. Up next, what exactly lives inside a wallet and why it matters? A wallet stores keys, not money itself. Keys sign transactions and prove control of assets. Software wallets live on phones and browsers. Hardware wallets keep keys offline on tiny devices. Losing a key can mean losing access forever. For everyday use, people keep a small hot wallet for trades and a cold wallet for long-term value. Later, I'll show simple steps to set up both safely. Smart contracts are programs on blockchains. They run automatically when conditions are met. Think vending machines for code. Insert a trigger and the contract delivers. They enable marketplaces, subscriptions, and automated splits without a middleman. But bugs in smart contracts can drain treasuries in seconds. That makes audits and bug bounties critical. Coming up, the tokens and NFTs that smart contracts power. Tokens represent value, access, or uniqueness. Fungible tokens act like currency. NFTs represent unique items, tickets, art, or game gear. NFTs can carry rights and rules, not just images. Some platforms use NFTs to gate events or memberships. But ownership on-chain doesn't automatically grant off-chain rights. That subtle gap causes surprises. Next, I'll explain decentralized apps and how communities organize around them. dApps connect user wallets to smart contracts to deliver services. DAOs are clubs that run on rules encoded in contracts and votes. Together, they let people build marketplaces, art collectives, and funding pools without traditional corporations. Members vote with tokens, and treasuries respond automatically. That can democratize decisions, but it also creates governance puzzles. Up next, how modular design lets developers snap services together like toys. Composability means building blocks interlock. One developer can reuse another's payment module or identity tool. It's like stacking Lego to build new machines quickly. This accelerates innovation, but it also chains risks. A single faulty module can affect many apps. That trade-off explains why audits and standards matter. Now let's step into the metaverse and define what that word really means. The metaverse is a network of persistent 3D places, not one app. Presence matters. You feel co-present with others instead of scrolling past them. Persistence means the world keeps its state, owners, and economy even when you log off. Identity and assets follow you between spaces when standards exist. The metaverse spans phones, AR glasses, and VR headsets. Next, concrete examples where this tech already shows up. Consumer metaverses exist today in games and social apps. Fortnite hosts concerts with millions of viewers. Roblox lets creators build entire economies and storefronts. VR chat creates intimate social rooms. These spaces prove people will gather in digital places. They also reveal moderation, safety, and economic questions. Now consider the industrial metaverse, where companies simulate factories and cities for optimization. Enterprises use digital twins to mirror factories, supply chains, and cities. Engineers run simulations to spot bottlenecks and save energy. Planners test traffic patterns before laying new roads. These practical metaverses deliver measurable efficiency and safety gains. They also demand accurate data and strict access controls. That brings us to the hard part, making assets portable between different worlds. Interoperability is the idea that assets work across platforms. In practice, standards are spotty and platforms may resist. Porting a skin from one game to another requires shared formats and business agreements. Some ecosystems will become walled gardens, others will embrace open export. For creators and users, interoperability determines choice and long-term value. Up next, how creator economics change with programmable royalties. Smart contracts can enforce royalties automatically whenever an asset sells. That gives creators recurring income without chasing platforms. Protocol-level splits can route revenue to teams, collaborators, and charities instantly. This can fix long-standing disputes about attribution and pay. But it also requires agreed norms and enforcement mechanisms. Next, we'll look at the real security risks everyone needs to know. Phishing and fake sites remain the top threat to wallets. Clicking a malicious link and signing a transaction can drain accounts in seconds. Bridges and smart contracts can be exploited at scale. SIN swaps and malicious extensions also attack users. Your best defense is hardware wallets, careful URL habits, and minimal approvals. Next, I'll map the specific risks inside immersive XR spaces. XR devices collect biometric signals, eye movements, gait, and voice. Those signals can reveal emotion, health, or identity. Spatial maps can accidentally expose the layout of your home. Deepfake avatars could impersonate people in real time. That raises novel privacy and safety challenges. The simplest mitigation is minimizing data collection and preferring on-device processing. Coming up, the identity shift from passwords to verifiable credentials. Decentralized identifiers give you cryptographic control over your identity. Verifiable credentials let you prove facts without oversharing. For example, a wallet can show you are over 21 without revealing your birth date. Selective disclosure and zero-knowledge proofs provide that capability. These tools reduce centralized honeypots of personal data and speed onboarding. But standards and wallets must mature. Next, we'll unpack zero-knowledge proofs in plain language. Zero-knowledge proofs let you prove a fact without revealing the underlying data. Imagine proving you passed a test without showing answers. This protects privacy while enabling trust. Companies use secure enclaves and on-device AI to keep sensitive processing local. These approaches become essential as identity and health data intersect with virtual spaces. Next, we'll scan the regulatory landscape shaping this technology. Policy will shape adoption. GDPR created user rights around data, and MiCA introduces crypto rules in Europe. AML/KYC requirements govern on-ramps and off-ramps. Expect jurisdictions to harmonize slowly and to demand more transparency. Compliance will increasingly look like code, programmable constraints in protocols. That intersection of law and technology will decide who can build and scale. Next, let's make 10 grounded predictions about the coming decade. Prediction 1. Wallets become common sign-ins for apps and events. Prediction 2. Passkeys and on-chain proofs reduce phishing and friction. Prediction 3. The industrial metaverse gets broad adoption for simulation and operations. Together, these trends shift logins, speed onboarding, and create new spatial jobs. Each prediction creates winners and losers in the ecosystem. I'll keep going with more predictions that affect creators and consumers alike. Prediction 4. Interoperability improves but stays scoped. Prediction 5. Creator royalties stabilize via protocol rules. Prediction 6. Tokens focus on utility rather than speculation. Prediction 7. Privacy tech like zero-knowledge proofs goes mainstream in consumer apps. These shifts make digital ownership more practical and less headline-driven. Next come AI, custody, and the regulatory finale in our prediction roundup. Prediction 8. AI and provenance tools prove where content and models originate. Prediction 9. Safer custody models like social recovery and MPC reduce key loss. Prediction 10. Regulation converges into clearer frameworks, making compliance programmable. These changes will make the space more reliable for mainstream users and institutions. Now that you know the landscape, let's walk through practical, low-risk steps to explore safely. Start small. Set up a reputable software wallet and write down the seed phrase offline. Practice on testnets or use tiny amounts for transactions. Use passkeys or authenticator apps instead of SMS. Move savings to a hardware wallet or cold storage. Revoke dApp permissions you no longer need and prefer audited contracts. Try a token-gated newsletter or a browser-based 3D meeting to learn what feels useful. There's one more big misconception to clear up. NFTs are not just JPEGs. They are certificates that can carry rights and access. Blockchains are pseudonymous, not anonymous. Web3 won't simply replace Web2. It will blend with existing services. The metaverse isn't only VR headsets. Phones and desktops participate too. These clarifications matter when you decide where to invest attention or money. Before we wrap, let's recap the key moves you can make today and what to watch next. Recap: the internet is becoming read, write, and own. Wallets, smart contracts, and verifiable credentials enable ownership and portability. The metaverse offers places where identity and economy meet. Security and privacy matter more than ever. Start with small, practical steps and prefer audited tools. There's enormous opportunity here, but also real risk. In the next video, we'll walk through setting up a hardware wallet and a simple DAO proposal. Stay tuned. If you found this useful, like the video and subscribe for the next tutorial where we set up a hardware wallet and build a simple DAO proposal. Drop a comment sharing which use case you want covered first.